Okay. Good morning, everyone. Hope you all can see my screen and hope you all can hear me properly. So, welcome to Software Process Modeling lecture series. So, we are going to start the very first lecture. So this is an introduction lecture. I won't take much time for the introduction lecture. Okay, so we'll do very slowly. And if you have any questions, you can ask me anytime. So you can just raise your hand or else you can unmute your microphone. Or you can ask anyway. If not, you can drop me the message. Okay, so this is software process modeling, right? First of all, can you confirm that you can hear me properly? And you can see? Okay, okay. So this software process modeling is more or less equal to software engineering 1. Now here the basement of software engineering module, right? So we are going to do some of the other modules like software engineering and software engineering 2. Likewise, there are some other modules in the previous semester. So this is the basement. So this is more or less equal to software engineering 1. Okay. So when it comes to the software process modeling, so first of all, we'll go to the session outcomes. So here we are going to discuss the introduction first, right? So what are the CE assessments that we have and what kind of final examination that we have and what kind of lectures that we have. So likewise, we are going to talk about introduction, and then we are going to talk about the introduction of the SPM, the first lecture of the SPM. Okay. So then, now first of all, I just need to tell it to you. So we are publishing each and every notice and each and every lecture material and each and every recording in the course web. So the course web is the place that you can find lectures, tutorials, recordings, and the results and each and every notice. Okay. So this is the enrollment key of the course web. It's capital IT 1060. Capital IT 1060. Right? So you can enroll to the course web by your own and you can find each and everything there. So at the moment, I haven't done the first lecture. Once I done this one, I'll surely upload lecture slides and the recording. Okay. So then, now these progression criteria you can read later on. So we are moving to module introduction, right? Module introduction. Now here we have course web as I already mentioned. We have course web. The enrollment key is IT 1060. That is 2021 July page, right? IT 1060. That is July page. And there you can find each and everything. Now, what are the things that we are doing? In the SPM, the weekly, we are doing a lecture, right? So you can find the lecture materials in the course web. Also for the labs and tutorials. Now in normal other subjects, you have separate lab session and you have separate tutorial, most common subjects. But in here, SPM for the labs and tutorials, for the both labs and tutorials, we are allocating 2 hours for the week, right? So you can, in some weeks, you will be having labs. In some weeks, you will be having tutorials. Okay. So for all lab sessions and the tutorials, both labs and the tutorials, we are allocating 2 hours per week. Okay. So the tutorials also we are conducting as a lab sessions, or else we are conducting in the lab sessions if it comes to the physical level. And then Also, we are uploading additional recordings and the readings and the previous year recordings to the concept. So if you prefer, you can refer those as well. Okay. And then, now here, these are the learning outcomes of the software process modeling, right? So we are going to talk about different software engineering processes. Okay, so then then we are going to talk about describe the requirement engineering process and the components of the formal requirements document of a software project. So then we are going to talk about the requirement engineering, and then we are going to talk about the unified modeling language and how we can represent the requirements to the customer, right? And then we are going to describe the design strategies and the importance of design models. Okay. And then we at the latter part of the cycle, latter part of the series of lectures, we are going to talk about the software implementation, testing, and the new methodology is called Agile or the Scrum. Modern software development methodologies or the Scrum we are going to talk about as the last lecture. Now, the assessment criteria. So this is the very important part in this introduction lecture. Now you can find the CA or the continuous assessment component at the moment. Since you have completed the very first lecture in the very first semester in your first year, at the moment you have a kind of an idea about the CA or the continuous assessment rather than the final examination. So MC 1 hour paper, it will be 1 hour paper, multiple questions, and the minus marks also there. Even it comes to the physical context. That means if it will assume that all the things normal, and if you are operating normally, also the midterm examination is an online one, right? Okay, so that is 1 hour MCQ1, that is 30% marks are there, multiple choice questions, and the minus marks also there in the midterm examination. And then when it comes to the assignment 1 and assignment 2, so those ones are very important. Assignment 1, normally we are publishing it on 4th week. 4th week we are giving it to you. We are publishing it in coursework, right? So the assignment 1 based on the use case diagram lecture. Normally we are completing use case diagram lecture in the 4th week. The same week we are publishing the assignment, and the deadline or the submission will be held on 7th week, the week before midterm examination. So that is 10%. And this assignment 1 is a group assignment, right? So you know at the moment, when it comes to the SPM or OC, IWT, and ISTM, for all 4 modules, there's a separate case study, the randomly allocating case study. So for the students, so that same case study is applicable to SPM also, assignment 1. So you have to draw use case diagram for that particular case study. That is a group assignment, but individual assessment also should be there, right? So we are assessing it individually also. So that is a group assignment. Even though it is a group assignment, individual marks also there. Okay. So that is assignment 1 happen before the midterm examination. Now when it comes to the assignment 2 based on the activity diagram lecture. So we are publishing it on most probably the 7th week, right? 7th week, and the deadline or the submission will be held on 13th week. Okay, so that is the CA component. Altogether for the midterm Assignment 1 and assignment 2, that is 50%. So then the final examination, normally it is a written one, physical paper. When it comes to the pandemic, it was a kind of an online one. However, that is 50% weight for the final examination. Okay, so the essay questions and the structured questions and the MC questions all are in the final examination. Okay. Now, normally, in order to pass the subject, you have to take 45 out of 100. When it comes to the whole component, you have to take 45. Okay. Any issues regarding the CA? Any issues regarding the CA? Any issues regarding CA?
No, madam.
Okay, so we'll move then. Now, when it comes to the assignments, that is 5 members group, right? So you will be having the randomly chosen case study. So, so the ISDM people is responsible for that one. They will assign you a case study, same case study applicable to this particular assignments also, right? So like I already mentioned, 2 submissions before midterm and the after midterm. Now, when it comes to the recommended test, right? So our reference book is Ian Somerville Software Engineering book, right? So that is 10th edition we are based on, right? So the Pressman books, our Pressman's books also you can refer. So any software engineering books you can refer, but the Ian Somerville 10th edition is the recommended text, right? Now, you can see the lab schedule and the lecture schedule, right? The week 1, normally the lab sessions are not there in the very first week. So this is very first week. So you don't have any lab session in this week. So we are starting lab session on second week onwards. So then in the second week, we are doing now this week as a lecture, we are going to do introduction. And then the second week, you are going to learn the software development life cycle. And the same week, you will be having your first tutorial based on the introduction. Okay. And then we have a requirement engineering as the third lecture on the week 4 and the use case diagram and the activity diagram. And then we are going to talk about the design and the testing and the implementation and the testing. And then at the latter part, we are going to talk about the modern software development methodologies called Scrum or the Agile. And you can see in the labs and tudes, the 2 hours slot. So we are some weeks you will be having the tutorials, and some weeks you will be having the lab sessions. So first 3 weeks, and you will be having the tutorials, and then for the use case diagram lecture, you will be having the lab session, and the activity diagrams lecture also, you will be having the lab session. And the agile also, you will be having a lab session. The rest, you will be having the tutorials. Okay. Now, we are moving to the software process modeling introduction. Software process modeling introduction. Now, before start the lecture series, I have to tell it to you. This is a kind of the comprehensive lecture series. So, if you are waiting until the last minute, sorry. If you are waiting at the last minute, you can't study each and everything properly. So, in order to achieve pass A, what you have to do after each and every lecture, you have to make your own set of notes and the summary. Okay, so even though we are describing several things in here, we are assessing some important parts. So you have to take those important parts as your summary, and you have to study those. So if you are waiting until the last minute, You can't achieve pass A, right? So the lab sessions are also very important because in some of the content we are not covering in the lectures, but we are covering those ones in the lab session. So those ones also we are assessing in the final examination. So the lab session and the tutorials also must. Okay. So then, so we are moving to the software process modeling introduction. Now, we are going to talk about what is the software. Now, at the moment, rather than me, you know the most common softwares, right? And then we are going to talk about what is software engineering and why we are studying software engineering. And then we are going to talk about what is a process and what are the activities in that process. Okay, and what is a software process model and what is the development life cycle then. And then as the professional software engineer, which type of ethics that we have to align. Okay, so we are going to talk about these things now, right? What is a software? Just any answer? What is a software? Now, already you have done some of the lectures, some of the module called IP in the previous lecture. Have you implemented softwares in IP? Have you implemented softwares in IP? Have you implemented softwares in IP?
Only small programs.
Just only small programs. Okay, so then what is a software? What is a software?
Collection of instructions.
What?
Collection of instructions.
Yes, we can say like that, right? So what else? Any other definitions? Now, what are the softwares at the moment that you're familiar with, right? So when it comes to the softwares, what are the softwares, the familiar softwares? We'll ask someone in the student list, right? So we'll say Lakshana. Any softwares? Anyone? Anyone?
Application software
Sorry, I didn't get you.
like Teams and Zoom.
What? I didn't get you.
Application softwares.
Yes, application
Like
software. Yes, what else?
application softwares.
Yes, application softwares. So when it comes to the Microsoft Word and Microsoft Office package and this Visual Studio and the Windows also kind of a software, right? So likewise, we can say software is not only computer programs, right? Software is not only computer programs. In IP, you have done small programs. But when it comes to the software, now when, for example, we'll say Microsoft Office, that is not only the computer programs, but also there are some other things. What are those? Associated documentation, configuration files, some other files that we need to operate it properly. So likewise, there are several things which are included, which are together, we can say it as a software, the combination of programs, associated documentations, configuration files, some other programs that we need to operate. So all together, we can say, that we can say it as a software, right? So that is not only the program. So you have to keep remember that is not only the program, but also there should be some other things, right? So these are the very familiar ones, right? So rather than this, you may use several things in your four-year degree life, right? So these are very common ones. You can see Microsoft.NET and Nero Burning ROM and the Instagram and the whatever the Photoshop and the Microsoft Word, and sometimes in the fourth year you may learn the Jupyter Notebook, right? Then the PyCharm. So there are several things, and NetBeans for the second year for the OP. So there are several softwares you are going to learn, right? So then, now this is what I already explained. In IP, you have done very small programs, right? Very small programs, but not the softwares. When it comes to the software, it's a kind of a complex thing, right? When we implementing a software, it is a kind of a complex one, right? Not like the writing a small program, right? So then here the library software. So when it comes to the library software, see what exactly we need. We need some presentation layers. The architectural wise, there are different layers in this particular software. The database is separately written, and some external applications also using some web server layers also there, and some different users are there. So that is a very complex one, not like a simple program. Okay, not like a simple program. Now here, when it comes to the program and the software, can you compare program and the software? Can you write three things comparing a program and the software? Differences of program and the software. Can you write three things? Now here, so software and the program. When it comes to software and the program, in the software, it's a kind of a large one, right? The complex one, not large one. It's a complex one, and the program is very simple one, right? Now, when it comes to the program, we don't. The most commonly in the program, the small program, there's only one single developer. But when it comes to the software, the team of developers are there. Now, when it comes to the Google, when implementing a Google, how many developers? There can be a number of the developers for that kind of a project. So when we are implementing a software, there should be the several developers. Not only one developer can do a software. And when it comes to the program, the size is very small, right? But when we come to the software, we can see several programs we are combined together to develop a software, right? And when it comes to the program, we can see very limited functionality, right? We can see only now simple program is, for example, we can see simple calculator. How many functions? 2, 3, or 4 functions are there. But when it comes to the software like Google, so Android Studio, the Photoshop, and the Microsoft Word, and the Jupyter Notebook, and we'll say PyCharm, likewise, there are several programs that we can combine together, and the multiple users also there. There are several people who use that software, right? But when it comes to the program, only one user, the single user is there. Okay. And when it comes to the program, the interface wise, the we don't need the interfaces for the program, but there can be some simple interfaces. But when it comes to software, now assume the Photoshop, right? How interactive those interfaces are, how detailed those interfaces are, how complex those interfaces are, right? So there can be very complex interfaces in the software. And then when it comes to the documentation, now in the lecture slide, you can see the program, you have a sparse documentation, and the software, you have a detailed documentation. Why? Now, in the program, most probably there's a one single user. There's one person who developed that one. The same person is going to use it. So no need to have that much detailed documentation. Okay, we don't need that much documentation with a small program. So we have a little information or the sparse documentation. But when it comes to the software, the different developers are involved to the software. So there are coding standards, there are some informations. So those are very important for that particular software. So we need that kind of a detailed documentation for that kind of a software. And when it comes to the program, we don't need user manual. Why? Only one developer and one user. So we don't need the user manual for the program. Program is very simple. If we use the commenting, that's all that we need. But when it comes to the software, we need a user manual. Okay. And there's another thing, right? Ad hoc development and the systematic development. Ad hoc development and the systematic development. So what do you mean by ad hoc development? The program, we don't need to follow systematic one. The way that we need, we can develop the program because we are the one who going to develop it and we are the one that going to use it. Most common context. But when it comes to the software, so that is not like that. That is a complex process. That is, the process is very complex. So therefore, we need very systematic process or systematic development. Otherwise, it may be a kind of a mess, right? If you are developing a sophisticated software, there should be a process or systematic development. Unless we can't develop it in quality manner, right? But when we come to the program is very simple. When we are implementing calculator, we don't need to worry about any process, right? So what we can do, the way that we need, we can implement that one, right? Okay, so that is the difference between the program and the software product. So you can see Microsoft Teams, right? Microsoft Team documentations also there when it comes to the Microsoft Teams, right? And the user manual and the help and the support, you can see several things. Now, when we take the software, there are two types of softwares that we have, right? The generic softwares and the customized softwares. So there are two types of software. Generic software. So what do you mean by the generic softwares? Now, when it comes to the common purpose one, the word processing and image editing and photo editing and video cutting and video merging and audio cutting, audio merging, those kinds of common scenarios, there are some common softwares. When we browse the internet, we can find the common softwares for those ones. So in the generic softwares means the people who develop the generic software, they have identified the common problem in the society and they have developed common softwares and they have make it available in the open market. So if we need anything, we can buy that one and we can use it. Now, if, for example, if I need to edit an image, I can easily buy the Photoshop and the license version and I can edit the image and I can use it. So that is a common purpose one, the generic software. So the common purpose one, right? So, but when it comes to the customized one, now assume I need, right? So assume I have organization. In that organization, I need assistive robot to handle each and every task. So that requirement is very specific one. So we can't find any common softwares for that kind of a specific requirement. So if so, I have to customize it. I just need the customized software. So what I can do is I can go to software development company and I can give my requirements to them and I can ask customized software for my requirement. So then they will develop the very specified software for my requirements. So those ones are customized softwares. So our requirements is very specific. We can go for the customized software if it is a common one. We can go for generic softwares. Okay. Now we are going to do a small activity, right? We are going to do a small activity first of all, right? Now I just need, now there are two activities actually, so both activities I am going to do together. Now first one is suggest something innovative. Now the people who are in this lecture, now most probably their purpose is to be a professional software engineer, right? The most of them people, they need to be a software engineer, the professional one, right? And they need to join IFS sometimes. Sometimes they need to join WSO2. Sometimes they need to be a data analyst, whatever, right? So the innovation is a must. So here this activity for the people who like to innovative something. Now in this one, you don't need to worry about the technical barriers. Don't think about the technical barriers, right? So don't think how we are going to implement this, whether this one is possible. No need to do that one. You can think beyond of the reality. At the moment, you know the reality, but the beyond of the reality also you can think, right? And our quote is, new ideas will lead you to highest point of software engineering. If you can think beyond of the reality, if you can search beyond of the reality, then we can surely come up with the novel ideas. So here, this activity for that kind of software engineers, right? Can you suggest something innovative? So that this one activity is together. This one we are going to do. So that can be something for the pandemic situation also, the day-to-day life, the communication, or the shopping, or any idea, right? So can you suggest something? Take 2 minutes time and don't think about the technical things and don't think about the reality, and we'll unmute the microphone and we'll discuss. Okay, take 2 minutes time and write down whatever the innovative concept that in your mind. Okay, anything that you need to share with us? Anything?
Fingerprint based ATM
Fingerprint based
ATM machine.
ATM machine. Yes, that's really good idea. But when it comes to the pandemic, I'm just worrying about the pandemic situation, about the fingerprint. Okay. So when it comes to the pandemic, now it's a good idea really. When it comes to the pandemic, how can we do the changes for that one? How can we accommodate changes to the when it comes to the pandemic situation? So in the pandemic situation, we are very worried about the touch and use some devices, right? Even we are very scared to use the cards also, right? So how can we do those ones? That's brilliant idea, right? So with having in Sri Lanka in near future, we can have that kind of thing. We'll see, right? What else? What else? What else? Students, I'm asking you all. Any other idea? Any other idea? I hope that you can see this one. Can you see this one?
Yes, we can. Madam.
Okay, so these ones are actually now they are coming up to 2030, right? Okay, now you can see some of the concepts, right? Some of the concepts, right? So we'll see the lecture. Give me 1 minute. Okay, so you can see that kind of innovative concepts are happening, right? When it comes to the 2030, so there can be a different changes, right? So in the fourth year also, right, is now when you come to when now at the moment you are in the first year, when it comes to the fourth year, you have to do a research project. In the research project also, we are assessing the novel and the innovative idea. So at the moment, so if you have some kind of idea, you can implement that kind of idea for your research project, right? So as a software engineer, there should be a kind of a wish to cater the novel technology and the Sri Lankan innovative platform, right? So that kind of a great advantage to you all when you're coming to the industry, right? So that's why we are having this kind of activity in this particular lecture. So here, now, when we come to the develop a real software, right? When we come to the develop a real software, there are some steps. There are some steps, right? So here we now any other software, the very first step is feasibility study, right? So now for example, we'll say we are going to implement ATM system with using fingerprint. We are going to implement ATM system with using the fingerprint. So for that one, the first step will be the feasibility study. So the feasibility study, what do you mean by feasibility study? Now, our idea is to implement a, fingerprint ATM system, right? So when it comes to the feasibility study, we have to check whether this particular idea is technically feasible and financially worthwhile. So why we are checking is technically feasible, whether this project is technically possible one or not. Whether this particular one is technically possible or not, right? And once we implemented this particular one, we had to check whether this one is financially worthwhile or not. That means once we implemented this particular one, whether this one is a valuable one to the in particular society or the country, right? So now you know there are some restrictions, the operational wise, the cultural wise, the social wise. There are some conditions. So we have to check each and everything. So technically wise that is possible, and financially it is valuable, and ethical wise that now when it comes to the Facebook, right? Some, for example, the Facebook, like by this whatever the social media like Facebook are banned in some countries. In the China also they ban the Facebook. So if we are implementing that kind of a system, that kind of a software to that kind of a country, that is a waste. So we have to check whether the technically, financially, culturally, and operationally, social wise, what are the things that we have to consider before implementing that one. We had to check whether the feasibility. Once we implemented this project, can we use that one in that particular country? Whether this project is possible to implement with using the current existing technology. Whether this project is applicable to their operational levels. Whether this project is violating their cultural levels. You know, in some Middle East countries, they have cultural issues. So we cannot accommodate some kind of ideas in the Western countries to the Middle East countries. So there are some issues, right? So according to each and every perspective, we have to check whether this project is feasible or not. The project is feasible or not. Then only, if we feel this project is feasible or possible, the technically is we have the experts and we have the technology, and if it is the financially also, that is a valuable one, and the culturally we don't have any issues, and the operationally also we don't have any issues, then we can decide this particular project is feasible. Then only we can start implementing this one. So how can we start? So we have to first of all gather customer requirements, and we have to analyze those. We have to gather requirements and we have to analyze those, right? So how can we gather the requirements? Now assume now we are going to implement fingerprint based ATM system. So if so, we can gather the requirements from the customers, the bank manager and bank assistant, and each and every staff in the bank, and the customers. Most importantly, we have to gather the requirements from the customer and then the bank people, because operational wise we need to gather their requirements also. So likewise, we have to gather each and every requirement and we have to analyze those. So once we identify their exact requirement, then we can design the one. Normally, you know, like house, right? For example, in house also, once we gather the requirements from the customer, we are not directly going to develop that house or build that house. We are designing it, we are planning it. So without having a proper design, we cannot implement it properly. So once you gather the requirements and once you analyze it properly, then we have to come up with a proper design. Then once we designed it, then we can go to the implementation. So once we develop, before giving it to the customer, what we can do is we can test it properly. We can conduct several testing and we can find whether there are any issues, any bugs, any defects in that particular system. Then only, once we confirm it has a minimal once we removed all the issues, only we can go and hand over the system to the customer. Then we can install, or we can deploy that system into that particular place, and then we have to do the maintenance. Not only hand over the system or installing the system into customer base, but also we have to do the maintenance also. Why we are doing maintenance? Why we need the maintenance? Because, right, so time to time their requirements can be vary, right? So if there's a new requirement, we have to accommodate those requirements, so those ones going to the maintenance. Even though we tested it million times, there can be some issues when it operates, right? So those ones we have to do it in the maintenance. Okay, sometimes we implemented that particular system in the to the Windows, but later on they need to change it to the iOS environment. So we have to do that one. So that is also maintenance. After delivering that project also, there are some there's some period we have to consider that particular software, and we have to give our service to them. Okay. So then, now what is a software engineering? Right? Can you please read it properly? Take 1 minute time. Okay, so when it comes to the software engineering, so this is IEEE definition of software engineering, right? Now, here you can see the black color ones and the red color ones. Now these red color ones are the keywords. Now you have to keep remember, right? So this definition is IEEE one. So here we are saying the software engineering is the application of a systematic, disciplined, and quantifiable approach. Why we are saying it's systematic? Why we are saying it's systematic? Because we are not going to do it in our way. The way that we need, we can't do like that way. So we need a particular process, or we need a particular plan to follow. Otherwise, we cannot create the software properly. So that is not the ad hoc method or the way that we need. So we just need to follow a process or the plan. So that is a systematic. And the discipline means not only the process or the plan, but also we are using the past experience, past technologies, right, of the previous software engineers and the previous software. So we are using those ones. So that's why we are saying it as discipline, right? So if it is any technology, right, any previous experience, that if we don't have anything, if we don't have any methodology, what we have to do, we have to create it and we have to take it. And then if it is quantifiable approach, once we create it, we can easily measure the quality of the software. So that is quantifiable approach. So here software engineering is systematic. It's not the ad hoc method. We cannot use the way that we need. We have used very systematic process or the plan to implement the software, and that is discipline one. Why we are saying discipline one? Why we are saying discipline one? Because we are using past experience, past methodologies, past technologies, and each and every concepts in the software engineering, right? And quantifiable approach. Why? Once we implemented that one, we can verify. We can verify whether this one is the appropriate one or not to development, operation, and the maintenance of the software. So that is the software engineering IEEE definition, right? Now, when it comes to the software engineering is not only the applying theories and methodologies and all those things, but also we have to use some other concepts, right? So software engineering is an engineering discipline with concern with all aspects of software production. Now, what do you mean by the engineering discipline? So that is a discipline one. Why? We are using existing theories, existing methodologies, and appropriate tools. If we don't have anything, what we have to do? We have to create something. We have to develop something and we have to use it. So that is engineering discipline. So we based on the existing theories, methodologies, and the tools. But if we don't have anything to our solution, what we can do? We can develop one. And we can develop one and we can use it. So that is engineering definition, engineering discipline. Right? Not only that, but also we have to use all aspects of software production, not only those ones. We have to consider the technical processes of the software development, the configuration management, project management, the development tools, and the theories, and support software production. Okay. So not only these theories and the methodologies, but also we have to consider some of the other concepts also, like configuration management, project management, and software, whatever the tools, developing the tools, those ones also we have to consider under software engineering, right? So then, now, what are the key challenges when we are implementing a software? What are the key challenges when we implementing the software? Right? Now, here you can see, right? Now, when we need a particular software for our requirement, what are the things that we as a customer we have to consider? We need a quality software. So deliver a quality software is a challenge. Not only the delivering software, quality software, but also delivering a quality software within the agreed time and agreed budget. Okay, so initially we have to agree with the time period and the budget. So within that time and the budget, we have to deliver quality software, right? If not, what will happen? The customer will they may not satisfy with the one that we are delivered. So that is a kind of a failure, right? And the thing is not like the construction level. Now, when it comes to the building, so we will assume that we are developing or we are building. So we are developing a kind of a building. So if so, we can see the floors are going on. So we can see the basement is completed and the first floor and the second floor. Likewise, construction level, we can see that one, right? But when it comes to the software product, right, we cannot see that software product is physically building, right? So that is intangible. So that is a challenge, right? We have to rely on the software engineering team. And the thing is, some of the software processes, right? And so some of the software processes, they are very specific to the organization by organization, right? And the products also like that. And then we have to worry about the cost. time and the quality are the key challenges. And the thing is, we just need to worry about the progress of the software development and the uh, the 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 way of the software. Some of the processes of developing software is very specific to some of the organization. Okay, so those are challenges to the software developing. Now, first of all, right, before starting the software development life cycles, we are going to talk about the process. Right, before doing the process, any issues up to this point? 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 Students, any issues up to this?
No, madam.
Okay. Now, when it comes to the process, now, um, when it comes to the process for the software development, uh, either software development or any other development, there should be a process. Now, when it comes to the tea making, so you all can make a tea, right? I assume like that, right? You all can make a tea. Can you write the process of tea making? Can you all make a tea? Hands of the people, raise your or drop me a message. The people who can make a tea. Out of 9, how many can make a tea? How many? Just tell me. Okay, write down the process of making tea. You can ask from mom, even if you don't know exactly. Can you just tell me what is the process of making tea? Now, not only the software, anything, if you are making, if you are developing, there can be a process, right? So, tea making process, software development process, right? Cake making process, right? So, anything, right? So, anything, there's a process. So, when it comes to the process, we have ingredients or the inputs, and then we can output. So, what are the inputs for the tea making? So, if we need to make a tea, what are the inputs? What are the ingredients that we need? What are the ingredients that we need to make a tea? We need tea leaves, the milk powder, sugar, hot water, right? Okay. So likewise, there's the ingredients, and there's the process, right? So making tea, there's a process, and then we can have output. Output is a tea, right? So likewise, the software also there's a developing, there's a process. So the software also there's an input and the process and the output. Not only the input, there should be another thing. What is that one? The entry criteria. Entry criteria means now for the tea making also, so we can check whether the hot water is boiled enough, whether this sugar is quality one, whether this milk powder is quality one. So that is entry criteria. We have to check the entry criteria when we take in the input. So then we can use it to the process, and before delivering it as output, we can check the exit criteria, whether this tea is quality enough, whether the sugar is enough, milk powder is enough, or whether it's boiled enough. Likewise, we can check the exit criteria. So likewise, the software also there's a process, right? So this is a making cup of tea. The people who don't know how to make a cup of tea, you can see here and you can try it out if you don't know exactly, right? So what we are doing, we are taking these ingredients and we are boiling the water and we are pouring it to the cup, and then we are taking the tea bags and then the sugar and the milk powder, and then we can stir it and we can have it as a tea, right? So we have ingredients, tea leaves, sugar, milk powder, boiled water, and the process is like this. First of all, we have to boil the water, and boil the water into a cup, and then put the tea bag inside the cup and leave it few minutes, and put sugar and milk and stir few seconds and arrange it nicely. In the process, you can see several steps are there. In this tea making process, you can see several steps are there. And then as an output, we can have a tea. So that is a tea making process. When it comes to the software process, when we are implementing a software also, we have set of inputs, we have output, and when we are taking the inputs, we have to check the entry criteria, and we are giving the output, we have checked the exit criteria. And the software process also, we can see set of interrelated activities. In here also, this tea making process also, we can see interrelated activities. First of all, we have to boil the water, then we have to pour into the cup, and then the tea bag. Likewise, interrelated activities are there in the tea making process. Likewise, in the software process also, we have set of interrelated activities. Now we are going to talk about the software development. So that's why we are going to learn this process. So the software process also is a set of interrelated activities and the tasks that transform input to the output. In the tea making also, what we have done, we transform ingredients to the output. In here also, the software, we are transforming the inputs to the output. Okay. Now, in the software development or the software process, right? In the software process, now when it comes to the software, like tea making process, in the software development process, we have these steps like boiling water and pour into the cup. Here we have several steps. What are those? Software specification and software development and software validation and software evolution. So what are those ones? In the software process, first of all, we have to identify, we have to gather the requirements, and we have to analyze it, and then we have to identify the functions of the software and the functions and the constraints or the difficulties of the software. So that is software specification. Then what we have to do, then we have to design the software based on those requirements, and we have to implement or we have to program it properly. Then we have to test it properly. Then we have to do the maintenance, or we have to accommodate any other changes that customer needs. So these are the steps of software process. The previously we discussed tea making process, and these ones are software process. Okay, so these activities, these interrelated activities are in the software process. So software specification, software development, software validation, and software evolution. Under software specification, what we are doing, we are gathering the requirements, we are analyzing it, and we are identifying the requirements for the functions properly. Now, when it comes to the fingerprint-based ATM, we can ask what are the things that customer needs from this kind of a software. And when according to the customer requirements, we have to identify exact functions. Then we have to develop under software development. We have to develop it, we have designed it, and we have to program it, and then we have to test it, and then we can deploy and we can install it in the customer premises according to their changes, according to the any other things we can do the changes. So that is software evolution. Okay, so those are interrelated activities in the software process. Now you have to keep remember, there is no universal process for each and every software. Now softwares are very, now when it comes to software, they are different one to another. Now safety critical systems are there, like tsunami alarming system, right? Now when it comes to the tsunami alarming system, according to the that kind of signal, that alarm should be functioning, right? So that is a safety critical system, the aerospace system. That is a safety critical system. And assistive robot, that is kind of a safety critical system. Now, for those ones, and when it comes to the normal system like library management system, hotel management, airline reservation, so those are very common ones. So, when we take a software to software, they are different. So we cannot say that we cannot say that this process is universal. There is no universal process that is right for all kind of software. So according to the software, according to the requirements, we have to use appropriate process. There are some different processes. Okay. Now, when we represent the software process in diagrammatic manner, we can say it as a software process model. When we represent software process in diagrammatical manner, we can say it as software process model. Now, when it comes to the software, we have the input, we have the entry criteria, and we have the activities, and then we have the exit criteria, and we have the output. We'll map the tea making first, then you can understand the software second. Now, inputs are tea leaves, sugar, boiled water, and milk powder. And entry criteria, we are checking whether these ingredients are quality enough. If not, we have to go again to the inputs. If it is quality enough only, we are going to the process. In the transform, what we are doing, we are converting these inputs to the output, right? So we can boil the water, and then we can pour into the cup. Likewise, we are converting our ingredients into output. So before delivering the output, we are checking the tea is quality enough. If it is not quality, again we have to go to the transform one, we have to do the changes. And if it is quality only, we are giving it as the output. Likewise, in the software also, we have the input. Before going to the interrelated activities, that means before going to the interrelated activities, we have for each and every step, we have entry criteria and the exit criteria. Each and every step we have entry criteria and the exit criteria, right? Now, when it comes to this software process model, right? Software process model, we can simply denote it as a software development life cycle, right? How we can say like that one? So we'll read this slide first. Now, software development life cycle model. Now, previously we discussed software process model. Now, when it comes to the software development process, we can say it as a software development life cycle model. In the software development life cycle model has a series of stages that has software product undergoes during its lifetime. Now, when we develop a software, there are series of phases or series of interrelated activities, right? Now, it is a descriptive and diagrammatic representation of a software life cycle. Now, when we are developing a software, there are several interrelated activities, right? Interrelated phases. So those ones are there, right? So when we represent that one in a diagrammatic manner, we can say it as a software life cycle. So when we consider these steps, right? These steps, we can say that is, those are the steps that software going through its lifetime, right? It's often referred as a software process model. And the same thing, we can refer it as a software development life cycle model. Okay. So here we are maps basic development activities to the phases in different ways. Okay. Now again, we'll go to the software process. Now we know in the software process, we have activities, right? Software implementation, software specification, software development, software validation, and software evolution. Okay, so those ones, when we represent it dramatically, when we represent it diagrammatic manner, we can say it as a software process model, right? So the same software process model, we can denote it as, we can recognize it as, we can say it as software development life cycle also. Why we are saying it's development life cycle? Because it has a series of stages that software product going, it's during its lifetime, and that is also another descriptive and diagrammatic representation, okay, of the life cycle. And that also the same name we can use, we can say it as a software process model, either software process model or the software development life cycle, both terms are common. Okay, and already in the software process there are 4 activities, so those activities we can map in these stages. Okay, now here these are the general software process models or the software development life cycles that we have. The waterfall, under waterfall we have classical waterfall and the iterative waterfall, and then we have prototyping model, and under evolutionary model we have incremental and we have a spiral, and then we have agile development at the as the last lecture of the lecture series. Okay, so those ones we are going to talk about in the next lecture, right? So can you just read this slide first? Okay, now we'll discuss your ambition, right? So just tell me, what is your ambition and what exactly job role that you are expecting in near future? Tell me, what is the ambition? What exactly you want to be? Students,
A, a data scientist.
data scientist. Good. What else? Any others? Any other students? Data scientist, and what? Who else? Gishan, what is your ambition? Gishan, are you there?
Yes.
Yes, what is your ambition?
Software developer in a bank.
Software developer in a bank. Good. That's very specific requirement, right? And then Akmal,
Ma'am, I just said data scientist.
data scientist.
I'm the one who said data scientist. Yeah.
Ah, okay, okay. Then who else? Dinuje? Dinuje? Are you there? What is your ambition?
Data analysis.
Data analyst. Good. Ayushka? Ayushka? Ayushka, are you there?
Sorry, cloud and
Clouden? What? I didn't hear you, Puta. Cloud? What? Okay, someone else telling software engineering. Okay, software engineering something, right? Okay, now you are actually your ambitions are varying. That's really good, right? Even though now at the moment you are in the very first year, right? So when it comes to the your ambition, right? So the based on the 2 years period, you can decide whether you can now if you are very interested about the programming languages, whether you are very interested about the data and the database management systems, and if you are very interested about the quality assurance, and if you are very interested about the requirement gathering and engineering, so you can decide your own ambitions, right? So starting from the business analyst or the system analyst and the software engineer, software programmer, software project managers, tech lead, and the data analyst, and the quality assurance engineer, and the system architect and system engineers, and there are network engineers, and the several job roles are varying, right? So these days the data analyst, data science is very trending and the emerging topic in these days. So the data analyst and high demand is going on, like software engineers, right? So software engineering is upcoming, still upcoming, right? Still upcoming. If you uh, you're willing to be a kind of a software engineer, you can easily, right, um, do whatever the things that you need exactly. That is upcoming trend still, right? Even though it's kind of a matured field, that is upcoming up to still upcoming, right? So the demanding jobs in each and every country, when it comes to the Canada, when it comes to the Australia, when it comes to the New Zealand, right? And the England, each and every place. And data analysts, the highly demanded, right? So you have to think about your profession, right? And you have to get ready to those ones, right? So while you're working in these 4 years, these are very important. Don't waste single day of it, right? You have to work for your future, right? So you're affording much money, so take that advantage, right? And you are very lucky. So that's even though it's pandemic, you are doing your studies, right? So then now this software engineering ethics, even though we mentioned it software engineering ethics, these ethics are very important to any of the job role. Even in my case, in the lecturing role, even in any other ones, right? It's very important, right? So why we need ethics, right? Software engineering is a very professional job category. Not only the software engineer, but also the several the jobs that you already mentioned. So those ones are very professional ones. So you have to be very careful about the ethics and the disciplines that you are aligning, right? Now, so now you can read it very clearly, right? So the slides no need to um, explain, no need to explain actually, but here, so these four concepts, right? The four things I'm just going to summarize, not going to explain each and everything very clearly. So these ones for you all, for your future and for your own purpose, right? So the confidentiality, now when you join to IFS, we'll assume like that, right? So you, as a professional engineer, you have respect for the company confidentiality. Okay, so you can't share your internal details, your internal process details with any other companies, right? The confidentiality is must. So when some company recruit you, so you have to be aligned with the confidentiality as a professional job role, as a professional software engineer, as a professional data analyst, as a professional QA, as a professional of banker or whatever the person, right? Not only these IT job roles, but also some people are going to some other ones, the banks, some other government institutions, some other places. For those ones also, as a professional person, what you have to do, what you have to respect their confidentiality and the competence. The competence means in current and contemporary society, you can see, right? In Sri Lanka, you can see the most of the people, they take whatever the things that they can't do, right? But as a professional people, as a professional software engineer or the data analyst or any other professional body, what you have to do, you have to take whatever the things that you can exactly do, right? Whatever the things that in your context, right? Now, uh, now, for example, I just like to be a president in this country, but I'm not going to be like that. Why? I can't do that one, right? Because to be a president, there should be to some sort of standard should be there, some sort of experience should be there, right? So we have to respect for those ones, right? Even though we have that kind of interest, we can't do that. So according to our capabilities, according to our knowledge, we have to select whatever the things that we can do, right? We can say now when you're in, we'll assume that we are working in the IFS, so we can say to the management, yes, I can do this kind of robotics project, we can do that kind of robotics project. Likewise, we can accept the work, but the thing is, that is a kind of a disrespect, right? According to your capabilities, you have to select your work, right? You have to accept your work, right? If you really know that you can't do that kind of work, you have to tell them, right? So that is a kind of an ethic. And intellectual property rights, right? Right? Intellectual property rights, you know, if someone has taken patent for that kind of thing, right? We cannot use the way that we like, right? We have to respect their property rights, right? You know it very properly rather than me, right? So you are using the license versions and you are using likewise. And if and along with this one, I have to tell now the plagiarism, right? The plagiarism, when it comes to the plagiarism, right? You can't use any other people, any other person's work as your one, right? If you are using a single word, you have to acknowledge them. You have to reference it, right? Unless that is a kind of misusing, that is a plagiarism, right? So then in your academic life, you have to be very careful. You can't use any other people, any other person, any other student's work as your own, right? So there are some tools that we can check with the plagiarism with, for example, the Turnitin, some other tools also there. If we submit your assignment now to the Turnitin, it shows each and every place that you reference, right? Each and every place that you take the content, right? If so, that is a plagiarism. So if you are taking a single word from any other resource, any other person's work, you have to acknowledge them, right? That is a kind of a ethic. And computer misuse, right? For example, at the moment, I feel that you haven't used the physical lab sessions in SLIT, but for example, in some students, when we are conducting the physical lab sessions in the whatever the SPM or whatever the subjects they are using, right? They are using Facebook and some other social media with using the labs at the same time. So that is a kind of a computer misuse. Even in the IFS, now when you are working, so they are not restrict any other applications from like in your machines, but they expect that kind of ethics from you. They don't restrict anything. They don't do the fireworks, they don't any proxies and likewise, but they expect that kind of ethics from you. You have to keep remember in 8 to 5. So this is working time. This is the study period. So we can't use it for any other purpose. Now this is time for do our professional work, right? So if you need to use Facebook, if you need to use any other whatever the social media, social networks or something, Facebook or whatever the Instagram or whatever the sites, then after that time you can use it. That is, also we respect your personal time. That is, you can do it in the break, you can do it after 5 o'clock, whatever the time, right? Not in the any other time. So that is ethics, right? So since you are very first year students, right, I'm going to tell it to you, right? Now, since I have done the very first lecture, I have good impression about the metro week end batch, because most of the students are talking with me and most of the students are very nicely behaving, no any other issues. So this batch is very good. That is the very first impression, the first impression of you all. Thank you very much for that one. So likewise, any other subjects also, you should be like that, right? So these ethics is very important for your career life in near future. Okay, so here when it comes to the case studies, right? So you are going to do the we are going to learn library management system in throughout the lecture series as the case study in SPM, but with using that experience, but with that knowledge, you can do your own assignment with using that kind of a, now what I exactly meant is now here we are going to do library management system for all of the examples in the lecture series, right? So in the use case diagram also we are taking the library management system, activity diagram also library management system. Based on that knowledge, you can do your assignment 1 and assignment 2. Okay. Okay, so this is the library management system case study. You can read it later on after the class. Okay, so then next lecture is software development life cycle models. Okay, thank you very much for listening, and we are going to upload the lecture and the recording to the course web. Please refer that one. If you have any issues, you can contact me. My email is